Hello everyone and welcome to Soros's classes. Today we will do with the vital statistics. This is the fourth video and today we will do expectation of life. Now what is expectation of life? The current expectation of life, usually denoted by E of x, gives the average number of complete years of life lived by the cohort L0 after the age x by each of Lx persons attaining the age. The complete expectation of life is usually denoted by E0 x, which measures the average number of years a person of given age x can be expected to live under the prevailing mortality conditions. It gives the number of years of life entirely completed and includes the fraction of the year survived in the year which death occurs, which on the average can be taken to half a year. Hence we have this total expectation or complete expectation of life, which is equal to Ex plus half. Now since the total number of years lived by Lx person of age x can be written as Tx is integral 0 to infinity Lx plus t dt. Now the complete expectation of life of a person attaining age x is obtained from the given relation. The relation is E naught x is equal to t of x, which will come from here, divided by Lx, where E naught naught is the expectation of life at the age 0 and it is the average age at death or the average longevity of a person belonging to a given community. Now students, please remember that there is a very important theorem on this, that is E of x is equal to summation of n is equal to 1 till infinity L of x plus n whole divided by Lx. This is a very important and a vital theorem. Now we'll study about the concept of stable population. A stable population is said to be stable if, number one, it has a fixed age and sex distribution. Fixed age and sex distribution. Number two, if constant mortality and fertility rates are experienced at each age. And the last point is if the population is closed to immigration or emigration. Now students, this was our stable population. Remember these, if these three points satisfy, then it becomes a stable population. It is a very important theorem or a definition. Please remember it. Now we move on to central mortality rate or CMR, that is central mortality rate. The central mortality rate or death rate is the probability that the person whose exact age is not known but lies between x to x plus 1 will die within 1 year following the attainment of that age. It is denoted by mx, which is given by dx by lx, or number of death within age interval x to x plus 1, death within age x to x plus 1 divided by average lx of the cohort in that interval, which can be further equated to dx by lx minus half of dx, which is equal to 2 of qx divided by 2 minus qx. This we get by dividing the numerator and the denominator by lx. Hence, mx can also be written in the term of qx, that is, qx is equal to 2mx divided by 2 plus m x by solving these two equations. Now, we'll do force of mortality. What is force of mortality? So far we have confined ourselves to the values of Lx for integral values of x, but since death occurs at all the ages and at every fraction of time of the year, Lx is a continuous function of x, and at any age x the rate of decrease in Lx is given by the expression limit t tends to 0 Lx minus Lx plus t divided by t, which is further equal to negative of limit t tends to 0 Lx plus t minus Lx divided by t, which is equal to del Lx by del x, where del Lx by del x is the differential coefficient of Lx with respect to x. Now, what is the definition of the force of mortality? Basically, it's at age x. The force of mortality at age x is defined as the ratio of instantaneous rate of decrease in the value of Lx to the value of Lx. That is, this, and it is represented by mu x, which is equal to minus 1 by Lx into del x by del x. It gives nominal annual rate of mortality, that is probability of a person of age x exactly dying within the year if the risk of dying is same at every moment of the year as it is during the moment of the following attainment of the age x. Thank you. Students, now we'll do some major proofs. Let the proof number 1 be, we need to prove is that del capital X by del x is equal to negative of del x. Proof. By definition, we have Lx is equal to integral 0 to 1 Lx plus t dt. Now, this is equal to derivative of RHS with respect to x, that is ddx of integral 0 to 1 Lx plus t dt, or this can also be written as integral 0 to 1 ddx of Lx plus dt, which is further is equal to 0 to 1 d dt of lx plus t times dt. Since lx plus t is a continuous function of x and t, hence it is further equal to lx plus t 0 to 1, which is equal to negative of lx plus 1, which is finally equal to negative of dx. Therefore, they're proved. Now we'll do proof number 2. That is, we need to prove dx is equal to integral 0 to infinity lx plus t dt. Now we know that dt of x by dx is equal to derivative of limits 0 to infinity lx plus t dt, which is equal to integral 0 to infinity ddx of lx plus t dx, which is finally equal to lx plus t limit from 0 to 1, hence 0 to infinity, which is L infinity minus Lx, which is equal to negative of Lx. Proved. Now we move on to the third and very important proof. We need to prove this. Now we know one condition, that mu x is equal to negative of ddx of Lx divided by Lx. Using this, we'll say that ddx of the LHS of the given proof is equivalent to which can be written as minus 1 plus mu x